All right, now we're looking at double angle formulas. What happens when I double the angle inside a trig function? We have one for sine. Sine 2 theta is 2 times sine theta cosine theta. We have one for tangent here that tells us how we find tan of 2 theta based on the values of just tan theta. But then look over here for cosine. There's actually 3 versions. They're all equivalent to each other, right? They're all equal to cosine 2 theta. You could, in fact, show that they're all equal if you start with the top one and just use the Pythagorean identity to either replace the cosine squared term or the sine squared term. You'll be able to arrive at each of the other 2 versions of the double angle formula for cosine. So we're going to begin with one where we're just going to simplify this expression. So we're dealing with the expression cosine squared 2x minus sine squared 2x. I'm going to do this here. I like to have, when there's a couple things going on inside the argument, I like to just emphasize that the 2x is the argument, is the angle inside the cosine squared and the sine squared. But to do this one, we just have to recognize, let's scan these identities. This looks an awful lot like the right side of this double angle formula for cosine, where theta is equal to 2x. So these identities work in both directions, right? So now we're just going to use it in the right to left direction, and this should be equal to cosine of 2 times 2x. I'm going to double that angle, and we get cosine 4x. All right, in this one, we've got another identity that we're going to show, that we're going to prove. And one thing I just want us to notice right off is that we're going to prove that 2 over 1 plus cosine of 2x, there's the argument inside the trig function here, is equal to secant squared x. The angles have changed, right? So I know that I'm going to have to use an identity that allows me to switch up the angle. This problem is in the section on the double angle formula, so it won't surprise anyone that we're going to use a double angle formula for cosine. But I just wanted to kind of bring that up because sometimes we'll see these in contexts that maybe are not quite as specific as ones where we know for sure we have to use a double angle formula. But always pay attention to a scenario where you need to change what the angle is. So we have 2 over 1 plus cosine of 2x. Now my goal is to get it to be secant squared x. Secant is 1 over cosine. So there are 3 versions of the double angle for cosine. And I'm going to use the one that allows me to rewrite the cosine of 2x using only the cosine function and not the sine function. And that is this middle one right here. So I'm going to replace cosine 2x with 2 cosine squared x minus 1. So on the bottom I have 1 plus 2 cosine squared x minus 1. Now we have in the denominator a 1 and a minus 1, so those cancel, and we have 2 divided by 2 cosine squared x. We can cancel those 2's. Now we've got 1 over cosine squared x, which is secant squared x, and that's what we wanted. Okay. All right, so now we have a word problem. Maybe that's a nice diversion from the proving identities type of problem. We're going to find the area of a right triangular piece of land. And it says to find the area of a right triangular piece of land, we can use the formula A equals 1/4 c squared times sine 2 theta, where c is the hypotenuse and theta is either of the acute angles. We're going to derive this formula. So I guess it's still a proof thing, right? But we're going to show that the area of this right triangle can be given by that formula. And so I guess maybe we'll just start by drawing the right triangle. So they said that C has to be the hypotenuse. I'll label these other sides as A and B. Theta could be either of the acute angles. I'll just let theta be that angle right there. And now what we already know about finding the area of a triangle, we know this, so we get to use it for free, that the area is 1/2 times base height. So that'll be 1/2 times A times B. Now what we'll do is use this right triangle and if you look at this right triangle, if we use SOHCAHTOA, and in particular the sine version, the sine part of that, we find that sine theta is B over C, which means that B is equal to C times sine theta. And if we use the cosine part, cosine theta is A over C, which means that A is equal to C times cosine theta. And now that we have these expressions for A and B, we're going to substitute these into in for A and B in this formula up here. So I've got 1/2 times A is C times cosine theta, and B is C times sine theta. Now what we have is 1/2 C squared times sine theta cosine theta. All right. So we have this product, sine theta times cosine theta, where those arguments are the same, right? They're both just theta. And what we're going to use here is the double angle formula for sine. The double angle formula for sine, you can look back on the previous page, but it looks like this. Sine of 2 theta is equal to 2 sine theta cosine theta. So if I just divide both sides by 2, we get that 1/2 times sine 2 theta is equal to sine theta cosine theta. And that's what we're going to substitute in for that expression. And finally we get 1/2 times 1/2 is 1/4. 1/4 times C squared times sine of 2 theta. All right, let's do one more. We're going to prove that sine squared plus, we're going to prove that the square of sine plus cosine is equal to 1 plus sine 2 theta. So I'm going to start with the left side. I'm going to start with the left side because I see an algebraic path forward. And that is, I want to square that sum, so let's just multiply it out. So we have sine squared theta across the top, sine squared x, and then plus sine x cosine x, and then another sine x cosine x down here, and then cosine squared x. All right. So we have sine squared x plus, now these are like terms here, right? Sine x cosine x, so I've got 2 sine x cosine x, and then plus cosine squared x. We can simplify this piece right here. We have the sine squared x plus cosine squared x, and if you add sine squared x and cosine squared x, you might recognize this as being the Pythagorean identity. That's equal to 1. That is always 1. So this is 1 plus 2 sine x cosine x. And we can get the desired result now just by recognizing that we can use the double angle formula for sine. 2 sine x cosine x is equal to sine of 2x.